Hi class, this is course 3, lesson 32 on probability. Several vocabulary words I want you to write down. Theoretical probability is found by analyzing a situation, and this is commonly called probability. So if you just see the word probability, this is the one that you're doing. But probability of an event is the number of favorable outcomes divided by the number of possible outcomes. Okay, so that's the formula you use. Experimental probability is found by performing an experiment, or we're using statistics. And that formula is the probability of the event is the number of times an event occurs over the number of trials. And so you can think of this as like basketball maybe. If you want to know what is the probability of making your next free throw, if in the last game or the last 20 attempts you've made 12, that would be an experiment. 12 out of 20 would be your probability if you reduce that. 12 makes out of 20 attempts. Sample space is a list of all the possible outcomes. You can use a table, a chart, a tree diagram, etc. However, these are not your list, not the list. Okay? I am not going to hunt through your tree diagram to figure out what your sample space is. You will list all of those values for me. The chance of an event occurring is probability that you express as a percent. You would hear that as, oh, it's 70% chance of rain today. Okay, that's probability. Odds are a ratio of favorable outcomes to unfavorable outcomes. And we often express that with a colon. In this case, 3 to 5, let's say the odds of winning would be 3, and the odds of losing would be 5. Okay, so 3 to 5. So in this case, we have a better chance of losing than we do of winning. There would be 8 outcomes altogether, 3 with wins, 5 with losses. The complement of an event is a set of outcomes that were not included in the event. Okay, and the complement plus your probability will always equal 1. Probability. There you go. So the complement plus the probability will equal 1. So we're just going to do a couple examples real quick to get you familiar with how this works. If you flip a coin 3 times, what is the probability of getting heads at least once? Okay, so I like tree diagrams, but you can do whatever you want. So on the first coin flip, we can get heads or tails. Okay, then on the second coin flip, we can get another set of heads or tails, or heads or tails. Okay, on the third coin flip, we can get heads or tails, we can get heads or tails, we can get heads or tails, and we can get heads or tails. Now, what this means is, for example, if I flip the coin the first time and I get heads, then I flip the coin from there. So this is, I got heads on the first coin flip, and then the second one, maybe I had tails, and then from there, the third coin, I could have heads or tails. Okay, so that's all we're doing, is we're stringing together all of the possible outcomes. So if you flip a coin 3 times, what is the probability of getting heads at least once? Okay, first off, here is my tree diagram. Let's list the sample space. Okay, so the sample space for this event would be heads, heads, heads. So if I go down this branch, heads, 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 or heads, heads, tails, heads, heads, tails, or heads, tails, heads, or heads, tails, tails, okay, or tails, heads, heads, or tails, heads, tails, or tails, tails, heads, or that last one, tails, tails, tails. So to find your this is how I want you to write your sample space. You just trace each of those branches till their end point. Okay, so now, what is the probability of getting heads at least once? Okay, so the probability of heads once, okay, at least. Maybe I should put that in there. At least once. Remember, the denominator is all of the possible outcomes. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8. 8 possible outcomes from this scenario, from this event. And how many of them have heads? Well, this one does, this one does, this one does, this one does, this one, and this one, not that one. So 7/8. And probability you can write as a fraction, a decimal, or a percent. And if it is a fraction, you would reduce it. So this would be 7/8. What is the probability of not getting heads at least once? So the probability of no heads, which is also called the complement, right? It's not, it's what the event was not, right? It's the set of outcomes that were not included in the event. So we wanted at least once heads, and now we want not heads, and that only occurs here. 1 out of 8. And notice that if we add 7/8 and 1/8, we get 8/8, which is all of the possible outcomes. Okay? Using a number cube, what are the odds, not probability, odds of rolling a number less than 2? Well, on a number cube, remember you have all 6 numbers, 1 through 6. So what numbers are less than 2? So less than 2 is 1, and all the others are not less than 2. So the odds would be 1 to 5. The sample space of flipping a coin twice, you would do the same thing that we did before, heads, and then heads, tails, and tails, then heads, tails, and then you would list heads, 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 tails, tails, heads, tails, tails. Okay, that's it. I think you have enough information to do the assignment. I'll see you in class.